Hello everyone, this is Eric Towers with Towers Arms. This is week 3 of FTE 217. We're talking about different components or major assemblies of the AR-15. I chose 3 of them. So the first component I chose is bolt carrier group. The second component I chose is magazine assembly. And the third component I chose is the buffer assembly. For the critical areas of the bolt carrier group, we have the gas key, the bolt locking surface, the gas rings, the bolt carrier itself, the firing pin hole, extractor, and ejector, and the cam pin. For the critical measurements, start out with the carrier. We got overall length of 6.675 inch, or we have a diameter of 935 thousandths of an inch. We have the bolt hole, which is 522.5 thousandths of an inch. Our gas port is 178 thousandths of an inch. Then on the bolt itself, we have overall length of 2.8 inches. The tail diameter is 251 thousandths of an inch. The cam hole is 309 thousandths of an inch. The lug diameter, overall lug diameter, is 743 thousandths of an inch. The lug thickness is 107 thousandths of an inch. This part here, how thick it is. The face, where the rear of the cartridge sits, is 379 thousandths of an inch, that opening there. The pinhole itself is 60 thousandths of an inch. Firing pin tip is 59 thousandths of an inch. The overall length of the firing pin, 3 inches and 273 thousandths of an inch. The extractor, we have a couple measurements on that. We've got the overall length of 1 inch, 238.5 thousandths of an inch. A thickness of 108.5 thousandths of an inch. The width is 245 thousandths of an inch. The hook groove, which is really right here on the very tip, the hook groove, 70.5 thousandths of an inch in the opening. We got a couple measurements on our gas rings. So we got three gas rings. 3 gas rings, and the size is 15.5 thousandths thick, 444 thousandths inner diameter, and 507 thousandths outer diameter. We're given 5 questions of each. That was question 1. Question 2, the potential malfunctions that may occur with the bolt carrier group. The potential malfunctions of a bolt carrier group are numerous. They range from failure to feed, failure to fire, failure to extract. Those range for everything from feeding, chambering, locking, firing, unlocking, extracting, ejecting, and even cocking. If there's any issues with the bolt carrier group, it can lead to any of those malfunctions. If there's been any damage or any improper modifications that were made to the bolt carrier group. Question 3, the damage that is likely to occur on a bolt carrier group. We have the bolt itself could crack, the extractor could break, firing pin could break, gas rings on the bolt are very common to wear out, the lugs can fracture. Question 4 is the training that a gunsmith should have to avoid causing damage to the bolt carrier group. The training that a gunsmith should know to avoid causing damage to the bolt carrier group is components and their functions, the head space, the maintenance and cleaning, troubleshooting and repair, materials and qualities. A skilled gunsmith can diagnose and fix bolt carrier group problems, perform maintenance and repairs, and offer advice on selecting the best bolt carrier groups. Question 5 for the first component. The additional components that interact with the bolt carrier group are the upper receiver, the barrel extensions, the gas system, the buffer system, the charging handle, the lower receiver, the magazine, and the forward assist. So the second component I chose is a magazine assembly. The critical areas of the magazine assembly are the magazine body, the magazine catch notch, which is how high the magazine catch interacts with the bolt, the magazine spring itself, but the floor plate and the base plate. Some of the critical dimensions are the depth of 2 inches and 310 thousandths wide, 2 inches, 310 thousandths deep, 808 thousandths thick. Our magazine follower that hits the bolt catch protrudes up 216 thousandths of an inch. The height of the mag catch, top of the magazine body to the top of the mag catch, is 1 inch, 121 thousandths. Question 2 for the second component: potential malfunctions that can occur if the magazine assembly is damaged or improperly modified. You could have failure to feed, magazine not seating, magazine won't drop free, magazine rattles around when it's loaded, inability to fully load a magazine, magazine falls out while shooting, damage or deformation of the magazine body. Some of the training that gunsmiths should have when interacting with a magazine assembly would be the basic magazine handling, magazine maintenance, and magazine inspection and cleaning. Some of the training that a gunsmith should have when handling or dealing with magazine assemblies would be there's also regulations with multiple states where you're limited based on the capacity of the magazine. Like in New York, where we are limited to a 10-round magazine. The additional components that interact with magazine assembly are the lower receiver and the bolt carrier assembly. The third component I chose is the buffer assembly. Critical areas of a buffer assembly are the buffer itself, the buffer spring, and the receiver extension. Some of the critical dimensions of the buffer assembly: the tube length is either going to be 7 1/4 or 10 inch, depending if it's rifle or carbine. The outer diameter of a mil spec is 1 inch, 148 thousandths. A commercial tube is 1 inch, 168 thousandths. The 4 different sizes for buffers that I found: we have a 2.5 inch, 3 1/4 inch, 5.3 inch, and 5.9 inch. From 3 ounces up to 5.4 ounces. They have a diameter of 701 thousandths of an inch. The buffer spring ranges from 10 inches and 62.5 thousandths of an inch up to 11 1/4 inches. A rifle spring ranges from 11 3/4 inch up to 13.5 inches. The number of coils on the buffer spring range from 37 all the way up to 42. The potential malfunctions that may occur with a buffer assembly if it's damaged or improperly modified: failure to extract, failure to feed, failure to eject, and failure to fire if it does lock into chamber. Some of the training that a gunsmith should have when working or modifying any type of buffer assembly is to know the proper overall length, the proper tension or the number of coils, the proper weight of the buffer that is being used, and the correct size of buffer tube. Additional components that interact with the buffer assembly is the bolt carrier group and the upper receiver. In conclusion, I chose 3 components, went over 5 different questions for those components, the critical dimensions associated with the components, the potential malfunctions, what likely is to get damaged, what training a gunsmith should have, and any additional components that interact with them. Thank you everybody for watching. This is Eric Towers with Towers Arms for FTE 217, week 3.